In this video, I want to go over an example practice problem with applying formal charges in order to determine the most stable Lewis structure. So I promised I would come back to this when I introduced exceptions to the octet rule in one of the previous lectures, and I will make good on that promise. So when we talked about exceptions to the octet rule, one of the ones that we mentioned is incomplete octets. And I told you in that video that that boron is comfortable with an incomplete octet, and I gave a little bit of a hand-wavy explanation as to why. Now that we have formal charges, I can give a little bit more teeth to that explanation of why this structure, which is an exception to the octet rule, is more stable than this structure, which follows the octet rule. Right? So going off of these two Lewis structures, let's calculate the formal charge for each atom and determine which one would be the most stable structure. So let's first calculate the formal charge on boron in this structure. So the characteristic valence for boron is going to be 3, right? Characteristically, it will have 3 valence electrons. And we're going to subtract from the number of dots. It has no lone pairs, so there's no dots there. But it does have 4 bonds, so we have 4 bonds there. And so that's going to give us a formal charge of -1, right? So we have a -1 charge at the boron. Now we have 2 different types of chlorines in this molecule. We have this double bonded chlorine at the top and these single bonded chlorines at the bottom. So first let's calculate the formal charge for the double bonded chlorine. So I'm just going to put a double bond here, Cl, right? So this is the formal charge for the double bonded chlorine. Now for chlorine, its characteristic valence is 7. Looking at the one with the double bond, we have 4 dots for the 2 lone pairs, plus 2 dashes for the bonds that it has with boron. So that chlorine is going to have a +1 formal charge. So a formal charge of +1 there. And if we look at the formal charge for the single bonded chlorine, right, we get, again, a characteristic valence of 7. But for these single bonded chlorines, it has 3 lone pairs. So that's going to be 6 lone electrons. And it only has 1 bond. So that's 1 dash. So that's going to give us a formal charge of 0. So the absolute sum here, right? So again, remember, we're taking the absolute value. This is the absolute sum. So you got 1 plus 1 plus 0. So that's going to give you an absolute sum of 2. Okay, so now let's do the exact same thing with this structure that's an exception to the octet rule. So calculating the formal charge for the boron, right? We have, again, a characteristic valence of 3, minus, again, we have no lone pairs, so no dots, plus 3 dashes. That gives us a formal charge on the boron of 0. And we only have 1 type of chlorine here, just a single bonded chlorine with 3 lone pairs. So I'll just put the formal charge for chlorine. Characteristic valence in this case is going to be 7, minus, we got 6 dots plus 1 dash. So that's going to give us a characteristic valence here of 0. And so when we add up the absolute sum, here we get 0 for the absolute sum of all of the formal charges here, right? Because it's going to be 0 at each one of these chlorines and 0 at the boron. And whereas in this case, you got -1 on the boron here, +1 on the chlorine. So this is what I alluded to in the video where I was explaining the incomplete octet. You create this formal charge at the boron and the chlorine, which really flies in the face of electronegativity. You want those negative formal charges to be on the most electronegative atom. And in this case, it's not. This negative charge is residing at the least electronegative atom. And it has a higher absolute sum of formal charge than this structure. So in all respects, this structure is going to win out. And this structure can be eliminated as the most stable structure, right? So even though this one follows the octet rule, it creates an unstable structure by creating this disparity of charge, right? So oftentimes you'll be asked to either calculate the formal charge, or in more involved problems, you'll be given these types of scenarios where you'll be given 2 or 3 structures, or you might be asked to produce multiple Lewis structures and determine which one is the most stable structure. Formal charges are going to be your best tool to be able to discern which structure is most stable.